Hi guys, so I wanted to give you some more help on some of the math menu choices. So the one that I want to go over right now, well actually two, are these two boxes here. They're on the part that says 5 MBT2. And these two boxes show a really super important concept that we talk about in 5th grade. Let me read the box on the left here. Explain what happens to the zeros in a whole number when you multiply it by a power of 10. Use this problem with your explanation if needed. And then the one next door says, explain what happens to the decimal point in a whole number when you divide it by a power of 10. Use this problem with your explanation if needed. Okay, so what I'm going to do is I'm going to show you those two example math problems to kind of walk you through how these two concepts work. And this is review. This is something we've already done, but it's been a while. We really talked about a lot of this at the beginning of the school year, so I'm glad to be revisiting it and keeping it fresh in your mind. So the first thing I'm going to do is zoom out a little, and I'm going to write those two example problems down. So the first one they give us is 3 times 10 to the 4th. And then the second problem they give us is 4,300. Wait a minute, I think that might be a decimal point. Let's see. Let's see here. Yep, that's a decimal point. So it's not 4,000, it's 4 and. So let me fix that. 4 and 365 thousandths divided by 10 to the 4th. Okay, so we first need to remind ourselves what the exponent means. And when we're talking a power of 10 with an exponent, the exponent tells us exactly how many zeros that power of 10 is going to have. Or it tells us how many times 10 has been multiplied by itself. So here 10 to the 4th is the same as 10 times 10 times 10 times 10. It's 4 tens multiplied together, right? Which I know is a 1 with 1, 2, 3, 4 zeros. Cha-cha-cha slide, that's 10,000. Okay, so this problem becomes 3 times 10,000 because there's 1, 2, 3, 4 zeros there. Okay, so now a lot of you are going to want to like set this up vertically and put the 10,000 on top and use standard algorithm. However, we have a shortcut way that saves us time here whenever we're multiplying by a power of 10. So this is 3 times 10,000. So I'm going to start by bringing that 3 down. And 3 has an invisible decimal point to the right. It's 3 ones, so my decimal comes to the right of that. 10,000, we look at how many zeros there are, and we're going to jump that many place values. And we're going to jump bigger because these are whole numbers and we're multiplying. So when we multiply a power of 10 by a whole number, the answer is bigger, gets bigger, okay? Now remember, when we multiply by fractions, that rule doesn't hold anymore, right? All right, so here we go. 1, 2, 3, 4 places this way, and I rewrite my decimal point. I cross off my old. Now I see I have 1, 2, 3, 4 empty baskets, so I need to put eggs in those baskets. Can't leave them empty. I'm going to rewrite my answer underneath, and I'm going to cha-cha-cha slide. And my final answer here is 30,000. So when it says explain what happens to the zeros in a whole number when you multiply it by a power of 10, use this problem with your explanation if needed. Well, what happens here? I know that I'm multiplying by a power of 10, 10 to the 4th, and I see that my decimal point is actually moving 4 places to the right, or my number on my place value chart is actually shifting 4 place values to the right. So if this is our ones, tens, hundreds, and thousands place, and this would be then our 10,000s place, we're starting with the number 3, and we're going to multiply by 10 to the 4th. That shifts our digits 1, 2, 3, 4 place values bigger. Now, we can't leave these place values blank here. We know that we need placeholders there. Bring down my decimal point straight down, right? And then I see my answer is 30,000. Okay, so when we multiply by a power of 10, the digits shift bigger the same number of place values as the exponent, or the same number of place values as the zero in the same number of place values as there are zeros in the power of 10. Okay, let's look at the division sentence now. Okay, explain what happens to the decimal point in a whole number when you divide it by a power of 10. Use this problem with your explanation if needed. Okay, so we have 4 and 365 thousandths divided by 10 to the 4th. Now, again, we know that 10 to the 4th is that 10 times 10 times 10 times 10, or 10,000 here. So I can rewrite this as 4 and 365 thousandths divided by 10,000. Okay. So what's different here? Well, we're dividing, and when we divide a whole number, a number bigger than one whole, here it has decimal points, but we're dividing it by a power of 10, we're going to jump that decimal point the opposite direction. We're going to make that smaller. So we have 4 and 365 thousandths, and we are going to divide that. Well, I think that their problem, when they made this problem, they didn't really think about what direction they were going to move their decimal, because when we divide, we need to move our decimal this direction and make the number smaller. So we're going to jump the decimal 1, 2, 3, 4 times, right? 1, 2, 3, 4. So my new decimal is here. Cross off my old decimal. Okay, we need zeros in each of those empty baskets. So my answer becomes 3. Okay. It becomes this number here. Now, my push for you guys is figure out how you would say this number. It's 4,365, and then we need to name this place value. Well, in math in 5th grade, we've never gotten up to that place value yet. So maybe do some research, look online, see if you can find a place value chart that goes all the way out 1, 2, 3, 4, 5, 6, 7 place values to the right of the decimal, or see if you can figure it out knowing what you know about the place value chart and how the different place values change. See if you can figure out how to read this number using place value understanding. So essentially, to answer the question that was on the math menu, explain what happens to a decimal point in a whole number when you divide by a power of 10. The decimal point is going to shift to the left when we divide by a power of 10, and it's going to shift the same number of place values that are indicated in the exponent, or the same number of place values that there are zeros in the power of 10. And likewise, on a place value chart, trying to make this as long as I can. So here's our ones place, so our decimals there, tenths, hundredths, thousandths, and so on. I'm going to leave those blank there because I don't want to give you the answer as to what place value that would be yet. But if we're starting with 4 and 365 thousandths, and we're going to divide by 10 to the 4th, each of those digits are going to shift 1, 2, 3, 4 place values smaller. Well, I don't have enough place values drawn here. Okay, we bring our decimal straight down, and we need place value holders here to give us that final answer, right? All right, so if you can figure out what this how you would read this using place value understanding, I'd like you to send me a message in Schoology to let me know what your guess is or what you think it might be. Even if you're not sure, like, try to continue to label these place values given the pattern we already have. We have 10th, 100th, 1000th. What would come next? All right, guys, good luck with that, and I'll talk to you later.